Hello everyone, myself Ankur Patel, and today we are going to learn sectional orthographic projections. So in this first session we will discuss the basics of sectional orthographic projections. So let's start. So the very first thing is why sectional orthographic projections are used, or why it is required to take the section of the object. So sectional orthographic projections are used to understand the inner details of the complex object. So when the object is complex from inside, there will be many hidden lines in the views of the object or in the orthographic projections of the object, and it will be difficult to understand the orthographic projections. Therefore, to understand the detail of the complex object, sectional orthographic projections are used, or it is required to take the section of the object to understand the inner details of the object. So if the object is too complex as seen in this figure, that means in the views of the object there are too many hidden lines. So at that time, to understand the orthographic views of the object, it is required to take the section of the object. Now let us discuss the point to keep in mind while taking the section of the object. So the first point is orthographic projections of complex object are drawn after imagining it as an object cut by imaginary planes parallel to the principal reference planes through the details of the object, and the imaginary plane by which the object cuts is known as the cutting plane or section plane. Second point is portion of the object between cutting plane and observer is imagined to be removed, and then the object is viewed by the observer and projections are drawn. So the projection of the cut object is known as sectional view or sectional projections. Generally, hidden lines are not drawn in the sectional view. In sectional views, the shape of the section, visible edges and contour of the object behind the section planes are drawn. So in sectional orthographic, in the view in which we have to take this section, we are not going to show the hidden lines, and we are going to show the shape of the section, visible edges and contour of the object behind the section plane. Now next is when one view is drawn sectional, other views are drawn as if the object is not cut and the object exists as a whole. That means other views are not affected by taking section in one view. That means if you are taking the section in the front view, the top view and the side view of the object will remain as it is. But cutting plane line is shown in the non-sectional views to locate the sectional plane, and arrows are drawn to show the direction of the side. So we have to show the cutting plane line in the non-sectional views by showing the arrows to show the direction of the side. Cutting plane line is also known as the line of the section or trace of the cutting plane. Now next is the portion of the object cut by cutting plane and touching the cutting plane is shown by drawing hatching or section lines in them. Hatching or section lines are drawn thinner than the object lines. Normally hatching lines or section lines are drawn at an angle of 45 degrees, and hatching lines are evenly spaced at about 2 to 3 mm apart. Now let us see the sectioning rules for machine elements like ribs, rivets, webs, shafts, pin, nuts, bolts, washer, keys and cutter. So whenever the cutting plane is passing through the above machine elements, that means from this all machine elements, and if cutting plane contains the axis of the above machine elements, then they are not sectioned. However, when the cutting plane is cutting elements perpendicular to the axis of the above machine elements, when section is taken and in the projection hatching lines are drawn. So if cutting plane does not include axis, then these elements are hatched. Now let us discuss all these points by using an example. So in this example we have to cut this object. This object is a hollow cylinder by using a cutting plane which is parallel to the horizontal plane. So we have to cut this object to observe the internal parts of the object. And after taking the section, we have to remove the part which is in between the observer and the cutting plane. So after removing the object which is in between the cutting plane and the observer, the object will look like this. So this is the sectional part of the object. So we have to remove the portion which is in between observer and the plane. That means the upper half portion is imagined to be removed. So here we have removed the upper part. So after removing the upper part, the object will look like this. Now we have to draw the hatching line in the part of the object which is in contact with the cutting plane. So this part will remain in contact with the cutting plane. Now we have to observe the top view. So section part will be as shown in the figure, and true shape of the section portion will be in the top view. So if you observe the top view, the true shape of the section will remains in the top view. So this will be the top view of the object, and in the part of the object which is in contact with the cutting plane, we have to show the hatching lines, and hatching line should remain and incline at an angle of 45 degrees to the XY reference line, and distance between each section line should remain 2 mm to 3 mm, and the front view will remain as it is. So observing from the X direction, the front view will be 2 concentric circles. Now let us discuss the types of the cutting plane. So there are basically 3 types of cutting plane: cutting plane parallel to the principal vertical plane, cutting plane parallel to the principal horizontal plane, and cutting plane parallel to the profile plane. So first is cutting plane parallel to the vertical plane. So when an object is cut by a plane parallel to a principal vertical plane, then the real or true shape of the section is observed in the front view, and section plane will be seen as a cutting plane line in the top view. So if the cutting plane is parallel to the vertical plane, that means right now the cutting plane is a vertical cutting plane, observer will remain over here. This will be the object, and we have to remove the part of the object which is in between the cutting plane and the observer. So the section object will look like this. So right now the observer is in this direction, so we will get the true shape of the section in the front view. So we will get the true shape of the section in the front view, and top view will remain as it is. So observing from the top direction, the top view will remain as it is, and in the top view we have to show the cutting plane line by using a arrow at the ends. Now next is cutting plane parallel to the principal horizontal plane. So if the cutting plane is parallel to the principal horizontal plane, then the real or true shape of the section is observed in the top view. Section plane will be seen as a cutting plane line in the front view. So when the cutting plane is parallel to the horizontal plane, right now the observer is over here, so the section will generate in the top view. So we will observe the front view from this direction, section will generate in the top view because we are taking the horizontal cutting plane. So after taking the section of the object, we have to remove the part of the object which is in between the cutting plane and the observer, because right now we will get the section in the top view, the observer will be over here. So we have to remove the upper part of the object, and after removing the upper part of the object, the section object will be like this, and in this part we have to show the hatching line because right now the cutting plane is in contact with this surface. So we will get the section in the top view, that means true shape of the section will be in the top view, and we will draw the cutting plane line in the front view, and front view will remain as it is. So this will be the front view in which we have to show the cutting plane line over here, and the true shape of the section will be in the top view. Now next and last is cutting plane parallel to profile plane. So when an object is cut by a plane parallel to profile plane, then the real or true shape of the section is observed in the side view, and section plane will be seen as a cutting plane line in the top view and the front view. So now we have to cut this object by using a cutting plane which is parallel to profile plane. Right now the observer is over here, so now we have to take the section of this object by using a cutting plane which is parallel to profile plane. So section will generated in the right hand side view. We will observe the front view from this direction, so this will be our right hand side view, and from the top we will get the top view. So after taking the section, the two shape of the section will generated in the right hand side view, and the part of the object which is in contact with the cutting plane is shown by the hatching line, or by drawing the hatching line. So this will be the front view of the object, this will be the top view, and this will be the side view. So the real or true shape of the section is observed in the side view, and in the front view and top view we have to show the cutting plane line only by showing the direction of the section. Now let us discuss the types of the sections. So first is full section, second is offset section, and third is half section. So let us discuss the full section. So in the full section, the view is made by passing the straight cutting plane completely through the part. That means we have to take the section of this object by using a cutting plane which is completely passing throughout the part. So we have to take the cutting plane like this, which should be completely cut the object. That means from this edge to this edge. So we have to remove the half part of the object. So after removing the half part, we will get the section in the front view observing from this direction. So the cutting plane line will shows in the top view. So in the top view we have to show the cutting plane line over here, and in the front view we will show the section like this. So right now we have taken the full section of the object. Now next is offset section. So in the offset section, the view is made by passing the banded cutting plane completely through the part. That means from one portion we have to bend the cutting plane like this. So here we have to take the straight cutting plane, then after we have to bend the cutting plane over here, after we will take the section by using a flat cutting plane, then after we have to bend the cutting plane like this. So we have to cut the object like this. So we will get the section like this. So cutting plane line will shows in the top view observing the front view from this direction, and we will get the section view in the front view of the object over here exactly. Now let us discuss what is half section. So in the half section, the view is made by passing the cutting plane halfway through an object and remove a quarter part of the object. So if the object is like this, we have to cut the object like this. We have to take the cutting plane like this, and we have to cut the object like this, and then after we have to remove the quarter part of the object. So now we will show the cutting plane line in the top view, and we have to observe the front view from this direction. So observing from this direction, and this hole is going to be visible, and this part of the circle is going to be visible. So first of all we have to remove the hidden lines from the front view. So remove the hidden lines from the front view. This part is going to be visible over here, this edge is also going to be visible over here, and in this part we have to show the section. So this is the half section. So this is it for today. Thank you for watching. See you in the next lecture.